Day 2, we're going to talk about binomial probabilities today. How does the expansion of a binomial relate to probability? Then we're going to take like kind of a classic probability example here. We're going to spin a spinner. A spinner has 2 sections. The spinner is spun 3 times. What is the probability you spin gray all 3 times? And the notation for that would be what? I'm going to get gray, and then gray. And we write that as P, gray, gray, gray. Okay? So there's only one way to do that. I get gray, then gray, then gray. And then the next possibility is, well, I could get gray twice, right? And that is going to look like, well, I could get 2 grays first and then a white. Or I could get a white and then 2 grays, really. And that's really, the only possibilities for that, I could have a gray and then a white and then a gray. I apologize. So there are actually 3 outcomes for that. There was 1 possibility with all gray, 3 outcomes where there were 2 gray. If you spin and get gray once, I could have gray, white, white. I could have white, white, gray. I could have white, gray, white. Okay? So those are the probabilities I would have. And there's going to be 3 outcomes for that as well. 3 possibilities. And then the possibility you spin no grays. Well, what's that going to look like? That's going to be white, and then white, and then white. And there's really only one way to do that, is to spin white all 3 times. And I have 1 outcome there. All right, so you may not recognize this, but really, GGG is the same thing as G cubed. And GGW is G squared W, right? And then GWW is GW squared, and then WWW is W cubed. And what you have there is the binomial expansion of G plus W to the 3rd power, because I spun the spinner 3 times, okay? So you can see where a binomial expansion is going to have a relationship with like a binomial probability. All right? So we still have to kind of define some things. The probabilities of a binomial experiment, that's an experiment with 2 possible outcomes, success or failure, can be found by using the binomial theorem from yesterday. Except the exponents are switched. Okay, so it's going to look like N, C, R, and I'm going to have P and Q here, but instead of Q being to the R power, the P is going to be to the R power, and then the Q is going to be the N minus R. All right? We're going to kind of switch those around. All right? Here's why. N is the total number of trials. With our spinner example, it was 3. We spun it 3 times. Right? R is going to be my number of successes, right? Or the number of times I want it to happen. Now, P is going to represent the probability of success, and Q, since there's only 2 options, either success or failure, P is probability of success, and Q is the probability of failure. Now, since there are only 2 options, all right, either I'm going to succeed or fail, then I know P plus Q added together must always add up to 1. Right? That's going to be important because sometimes I'll only know the probability of success, right? Well, if I know the probability of success, I can subtract it from 1 and find the probability of failure. And there are all kinds of things you can help you use to remind yourself what these letters are that you need. NRPQ. Nick Rathbun plays quarterback, or Nina runs pretty quickly, okay? Anything like that to help you remember. Okay. The probability of guessing the correct solution on a multiple choice question is 1/4. So there's 4 choices, and you pick one, right? What is the probability of getting 8 questions correct on a 10-question exam? So you want to get like an 80, exactly an 80. Now that's not going to say at least an 80, because we're going to talk about those in the next video. All right, so this is a binomial probability. Either I get the questions right or I don't, okay? So I need N, R, P, and Q. All right, and the N is the number of trials. Well, the number of trials here is the same thing as the number of questions on the test. There's 10 questions, all right? And I want to get 8 of them correct. So I'm going to consider a success getting the question right. That just kind of makes sense to me, right? So my R is 8, because I want 8 questions correct out of a 10-question exam. Now, what is the probability that I guess the question right? 1/4. So if these have to add up to 1, if the probability I guess it right is 1/4, then the probability I guess it wrong is 3/4. So there I go. I have everything I need to set up my binomial probability. So I'm going to have, it's going to be 10 C8, and then I'm going to have P, and then I'm going to have Q. So the probability I succeed is 1/4. And the way I like to think of this is, how many times do I want to succeed? I want to succeed exactly 8 times. So I'm going to have 1/4 8 times. All right? And I only want to fail twice. So the probability of failure here is 2. There we go. All right, so what we need now is to evaluate 10C8, 1/4 to the 8, and 3/4 squared. All right, so I'm going to get this out of here. Let's go and have 10C8, 10, math, go over to PRB, choice 3, 10C8 is 45. So that is 45. All right, and now I need to do 1/4 to the 8. And here's a little hint. If I want to do this as a fraction, it's really going to be 1 to the 8th, 1 raised to the 8th, which is 1, over 4 raised to the 8th. So you see, as I do that on the calculator, it won't give me a decimal. I can figure out it's going to be 1 over 65536, 65,536. And then I need to do 3/4 squared. So 3 squared is 9, 4 squared is 16. All right, now this 45 I can put over 1, so I can multiply them as fractions. 45 times 1 times 9. 45 times 1 times 9. And I don't have to put the times 1 in there, right? But I do want you to think about, those aren't always going to be, there's not always going to be a 1 up there. Make sure you're multiplying all the numerators, okay? And then multiply the denominators, okay? 1 times 65,536 times 16. And that will give me 1,048,576. Okay, and I can have that as a fraction or as a decimal, either one. And I could even do it as a percent if it asks for a percent. I could take it, turn it into a decimal, and then multiply by 100 to turn it into a percent. All right, you flip a fair coin 7 times. What is the probability that all 7 are heads? So how many trials do I have? Right, I need Nina runs pretty quick. And n again is, remember, the number of trials, so that's 7. And I want to get all 7 heads. So we're going to consider it coming up as heads as a success. So I want 7 successes. What is the probability when you flip a fair coin that you get heads? I think that's 1/2, right? And the probability that you don't, then is also going to be 1/2. So I have 7C7, 1/2. How many times did I want to get heads there? 7, right? 7 successes and 0 failures. So this one's pretty easy because 7C7, remember, is 1. Okay? And 1/2 to the 0 is going to be 1. Now I just need to do 1/2 to the 7th power. So 1 to the 7th is 1. And then do 2 to the 7th. All right? 2 to the 7th power is 128. 128. So when I multiply that, I'm going to get 1 over 128. If I wanted that as a decimal, I would get that. And let's say I wanted to know the percent chance that I got it. I would multiply that by 100. All right, so it's like a less than 1% chance that all of them are going to be 7. Or sorry, all of them are going to be heads. The probability of rain in a certain city is 1/5 every day next week. What is the probability of rain exactly 2 days? Okay, so again, you need to decide what you consider a success here. All right, in this kind of problem, I'm actually going to think of it raining as being a success. All right, so the probability of rain in a certain city is 1/5 every day next week. What's the probability that it rains exactly 2 days? So it's in a week, that's 7 tries, right? We have 7 days. And I want it to rain on exactly 2. So I have considered raining a success. So the probability of rain is 1/5, which means the probability that it doesn't rain is 4/5. Okay, 7C2, 1/5, 4/5. And how many days did I want it to rain? Exactly 2. That means the days that it's not going to rain is 5. All right, so I'm going to evaluate that. 7C2 1/5 squared, 4/5 to the 5th, okay? So 7, math, go over to PRB, 7C2 is 21 over 1, right? And then 1/5 squared is 1/25th, right? And then I want to have 4/5 to the 7th, right? So I need 4 to the 7th, and I'm going to want 5 to the 7th. I'm going to want both those numbers, right? So it's going to be 16,384, 16,384 divided by 78,125, okay? In the interest of time, I'm going to kind of let you finish that. Multiply straight across, okay? All right, on to the next example. All right, the probability of the Syracuse University football team to win games this year is 1/6. What is the probability that they lose all 12 games that they play? All right, so N, R, P, Q. And this is one of the ones where there's just a couple ways to do this problem. I mean, it depends on what you want to consider a success. Maybe you hate Syracuse University football and you want them to lose all 12 games. That would be a success for you. So we'll do it that way. All right? They're playing 12 games. How many games do I want them to lose? 12. What is the probability that they lose? All right? The probability that they win is 1/6. So the probability that they lose is 5/6. And some of you are going to have trouble thinking of a loss as a success, right? But that's kind of what I've done this way. I could do it the other way and have 0 wins and have my R be 0 and my P could be 1/6. It would give me the same answer. All right, so this way I have 12, C12. My success is them losing, and I want them to lose 12 times. That's why 5/6 to the 12th. And the probability they win is 1/6. And I don't want them to win any. Okay? I don't want them to win. All right, so 12C12 is 1. All right? 5/6 to the 12th, well, we'll do that in a second. And then 1/6 to the 0 is 1. So really all I need to do is 5/6 to the 12th. Okay, so I have 5 raised to the 12th. And then I'm going to have 6 raised to the 12th. Hopefully I don't get too big a number to wind up with scientific notation. There we go, that's all right. But I do think I have a little bit of a trouble fitting that in there, so I'm going to kind of adjust and make a little more room there. 2, 4, 4, 1, 4, 0, 6, 2, 5 over 2, 1, 7, 6, 7, 8, 2, 3, 3, 6. And then 1/6 to the 0 was again 1, right? So there it is. There's a probability that they lose like all 12 games, right? Let's see what that is as a percent. Like, what's the percent chance that they're going to lose all those games? So I take 2, 4, 4, 1, 4, 0, 6, 2, 5, and then I divide that by my answer from before. Okay, and then I multiply it by 100. That's like about an 11.2% chance, right? It didn't ask it for it as a percent, but I know on the practice sheet I have tomorrow we have some percents. So I kind of wanted to go through that with you quickly as to how to do that. All right, and I have just a minute left here on my allotted time, so I guess I could finish this one here. All right, it's just going to be 16,384 times 21. All right, that's going to be my numerator over 25 times 78,125. And there we go. There is the probability that it rains on exactly 2 days. 344,000. 64 over 1953125. All right, 1 million. So there you go. It's less than 1. Okay, there you go. There is the probability of a binomial occurrence happening exactly a certain number of times. Thanks. Good luck.